Hi friends, I'm your colleague CS147. I'm going to explain the sixth experiment of compiler lab, that is the implementation of an assembler. So at first we are going to import all the header files. So we have to read the file and write it to another file. So we are using buffer reader and buffer writer, and here we have the implementation of hash table. So hash table is also imported. Then the file reader and file writer and the exception headers are imported to the headers. Then now we are going to start the program, and at first we are going to create a variable for the hash table, that is in this hash table OP we are going to enter the opcodes of the program, and in hash table symbol we are going to input all the symbols, and then we are going to read the file from program.txt, and we are going to write that to the index.txt, and we are reading it using buffer reader and writing it using buffer writer, creating a function for this. We can read and write into it, and now we are declaring string line and util, and a integer location counter and start both are given as 0. So for line not equal to null, if the line is not equal to null, then if the line is start, then we are going to split that line, and we are going to enter into title z of 0, and then the length of the thing is incremented, if it's incremented by 3, and the location counter is given as start. Else if start is equal to 0 and location counter is given as start, and we can write into the line. For address, each address is incremented by 3, and in the location counter we are going to enter the line, the opcode, the symbol, and we are going to write in it. And if the line is again end, then we are going to write the line. And in length is calculated by the location counter is incremented each time, and at last the value of location counter minus start value is given as the length. And now we are going to close the buffer reader and writer, and after that again we are going to create a new variable known as buffer reader br1, that is for the index.txt that is created already and written. So from this index.txt we are going to take the addresses that are generated. So at first if the line is not equal to null, and if it is start, then it is the header record of the object code. So the header record, there we give the header, then the title and the title of that program, and then 26 integer to hexa string start. That is, we are going to generate the address in hexadecimal format. So the hexadecimal format of the start address, and then with that we are printing a character symbol, and then the hexadecimal format of the length is updated to the head of the header text of the object code. And if it is end, then we are printing e, and after character symbol then we are going for the start address in the hexadecimal format. And now we are going to update the location counter values else, and then these are done at the first thing. And for the second pass we are going to generate the text area of the object code, so that we are taking the hexadecimal values from the location counter for each statement that is entered in the program, that is each line that is entered in the program. So text and to hexadecimal format, and then this is incremented by 3, so 3 is given. So object code equal to object code plus 26 from the opcode we are getting the opcode, and from the symbol table we are getting the symbol, and by adding those two values we are getting the object code for that line. And the location counter is incremented by 3, and similarly next thing is taken, and then the object code is generated. And after that If the line contains reserved byte, reserved word, then is equal to 3 into % of C of 3. And if it is reserved byte, it is location counter plus that address. And if it is word, then object code plus character symbol plus to 6 C of 3. And then we are going to print the object code there. And we are having the hash table. Then the hash table that is for the opcode, symbol and location counter and buffer writer. Here this is for writing the object code. So at first we are going to check if any of the symbols are not entered in the object code. We are splitting it according to the space, and if it is an opcode, then we are going to enter it in the opcode table, and if it is a symbol, then to the symbol table. And or else if there is not any change, label already exists, so no need of making any change. Then if the label name is invalid, then it will be printed as invalid label name. And if C of 1 equals word, then write integer to hexa string of location counter space line and put it to the symbol table. And if it is reserved byte, then 3 into integer % of C2 and putting it into symbol table. And if it is reserved byte also, we are going to put it into the symbol table. And after that we are going to take the inputs from the opcode table, and from the opcode table the inputs are taken and the value is calculated already, and we are referring it from the opcode table that is in the C drive, and the line is printed. Then for a line, if it is not equal to null, 0 of 0, then line dot split. If space is there, then opcode dot put C of 0 integer % C of 1. We are entering to the opcode. And before that we have printed the object code before itself, and that object code will be generated as the output. So now we'll see the different inputs. So at first we'll see the program. The program is copy start is from 4000. From there we have LDA alpha, STA beta, STS gamma. Then we are defining all this as reserved word of 1, and the program is entered. And in this operation table, opcode table, we have opcode for those two. And now we are giving opcode for STX of 45. Then in the adder text, if any function is needed to be read, then that is also to be included. Then we are having operation table, the program, and the program is written to this index.text. So now we'll run this one. After running, the object code is generated. First the header file is there, the name is there, that label of that program is there. Then we are having the starting address, the length of the program, and in the end record and the starting address. And for text records, each value is incremented by 3, and text records are generated. And here we have the opcode plus the address value. Now we'll see the intermediate code. So in the inner code, the copy address is 4000. In 4000, alpha is loaded, and in 4003, STA beta is loaded, and in 4006, STA gamma is loaded, and reserved byte for beta, gamma and alpha is also loaded accordingly to this session. And by this the assembler is generated and the object code is generated. The output of assembler is object code. By this the explanation of assembler implementation is over. Thank you for watching.